Okay, for example A, we are given 1 over 3 plus 2 over 5. What we do not have here is a common denominator. We have a denominator of 3 and a denominator of 5. Because the denominator tells us that this is something that has 3 parts in a whole, and this is something that has 5 parts in a whole. You could illustrate it like this. You could say that this fraction has 3 parts, and we have one of them. This fraction has 5 parts, and I'm not the greatest drawer, so you're just going to have to function with that a little bit. And it has 2 of the parts, but we're not talking about something that's the same. It's different. We must have a common denominator. So how are we going to go about creating that common denominator? Well, when we have small numbers like this, the easiest thing to do is just multiply these two denominators together, because then you're going to have a number that is a multiple of both of them. Later on in lesson 41, we'll get into greatest common factor, and we'll deal with some of the bigger numbers that we're going to deal with. But for the present, let's just multiply those two numbers together. If you have more than one fraction, which we'll see in a minute, we should be able to find a common denominator that we don't have to multiply all 3 of them necessarily. Although if you were to multiply all 3 of them, you could still get the same answer as long as you simplify your answer when you're finished. So if I take the 3 times 5, it's going to give me 15. So I know that I can make a common denominator for these two fractions that is 15. And it was an addition problem before, so it's going to continue to be an addition problem. If I convert this 1 over 3 to something over 15, and this 2 over 5 to something over 15, then I can simply solve the problem because my answer is going to be something over 15. So let's go through the process. What do I have to multiply this 3 by to turn it into a 15? Well, I multiplied it by 5, didn't I? So if I multiply this denominator by 5, the denominator-numerator same quantity rule says I must also multiply the numerator by 5. This is the process I'm going through. If I multiply this denominator by 5, 3 times 5 gives me the 15, and multiplying the numerator by 5, 1 times 5 gives me 5, I can convert the fraction 1 over 3 into the fraction 5 over 15, and it represents the exact same number. It's the same spot on a number line. I've just changed its form because it was convenient for me. Now the 2 over 5, the 5, I also turned into a 15, but I did that by multiplying by 3. So 3 times the 5 gave me the 15. Since I multiplied this denominator by 5, I must multiply this numerator by 5. 2 times 3 gives me 6. So I've converted the fraction 2 over 5 into the fraction 6 over 15. It means the same number, I've just converted it. So now all I have to do is add the numerators. The numerator 5 plus the numerator 6 equals 11, does it not? 5 plus 6 equals 11, and this is my final answer, 11 over 15. Now let's try one that has subtraction in it. Now example problem B is the same type of problem. It's a fraction problem, except this one is a subtraction problem. Again, I do not have common denominators. I have a 3 and an 8. The easiest way to find that common denominator when we have small numbers like that is simply to multiply these two denominators together. 3 times 8 equals 24. So I know my common denominator is going to be 24. It's a subtraction problem, so it's still going to be a subtraction problem. And this denominator I'm also going to change into a 24, which means my answer is going to have what as a denominator? 24. Because now I've got common denominators. Here I'm talking about a number that has 3 parts. I'm going to convert it to a number that has 24 parts. This is a number that has 8 parts, but I'm going to convert it to a number that has 24 parts. So my answer must have 24 parts. How did I turn this 3 into a 24? I multiplied it by 8, didn't I? So if I do that, 3 times 8 is going to equal 24. If I multiply this denominator by 8, I must multiply this numerator by 8. 2 times 8 is 16. Now, as we discussed in the introduction, you're allowed to use a calculator at this point. If you don't have your multiplication tables, check your answers in with a calculator. We don't want you to make a mistake in your answer when you had all the steps right. What this course is about is the steps. Can you follow the steps? So if you're not great with your multiplication tables, keep a calculator handy. Now this denominator 8, I also need to convert it to a 24. I did that by multiplying by 3. So 8 times 3 gave me the 24. Since I multiplied the denominator by 3, I must multiply the numerator by 3. 1 times 3 is also 3. Now I simply complete the addition problem. 16 minus 3 equals 13. So my final answer is 13 over 24. You always want to look and see if you can simplify your answer. In this case, it is already simplified, and we'll get into that more as we go and we deal with more mixed numbers and improper fractions down the road. But basically, your steps are always the same. Your goal is to have common denominators. If you do not have common denominators, you can multiply them by a number to turn them into a number that they have in common, that they're a multiple of. And really what you're doing here, in a sense, is you're multiplying this fraction by the number 1 in order to change its form. Now, you're saying, how did you get the number 1 in there, Mr. Lawson? Well, if I have, let's take the 3 over 3. I have the fraction 3 over 3. I have something, it has 3 parts to it, yes? And I have all 3 of those parts, so I have one whole, don't I? The fraction 3 over 3 is really the number 1. So you simply multiplied this fraction 2 over 3 by a form of the number 1. If I multiply anything by the number 1, I don't change how many I have, but this allows us to change its form so that we have common denominators. That's something we can work with and we can solve it. And that's what we're going to do a lot in algebra, is just change the form of things into a form that we can use to complete the next operation.